Okay, so we've been talking about evolution, and of course one of the great places for evolution is right here in Ecuador. One of the great landmarks of evolution is the Galapagos Islands. Darwin came to the Galapagos Islands about 150 years ago, and saw, as you are arranged here, that there were groups of organisms living in different places and different spaces. And I've asked you to bring different tools that you can use to represent bird beaks. How do you think what you have in front of you might represent what Darwin saw? You got the beaks, you got little dishes of food. How do you think that this might represent what Darwin saw?
Because there's evolution in different types, and so they can eat different things.
Okay. As it happens, in this first phase of the experiment, you're all going to be trying to eat the same thing. You haven't divided allopatrically yet. You haven't gone to your different islands yet. You're still, in this first phase of this experiment, operating off the same resource. Everybody has 20 kernels of popcorn in their bowl. When I give you the signal, I want you to try and feed yourselves. Okay? This hand, if you are right-handed, this hand is your stomach. Do not use your other hand to push the food into your mouth. Your mouth has to get the food. Your bird beak has to get the food. And I want you to deposit the food in your stomach, and we'll see who's able to get the most food by the time the food runs out. So I'm going to give you, at the signal, 2 minutes to collect as much food as you can. Hold on just a second here while I go into stopwatch mode. Everybody's ready? Everybody feels like they know what to do? Yes. Go. I hear food being lost to the environment.
Oh, okay. 4, 5, 6, 7. 12.
Okay, stop. It was only 1 minute, not 2, but I see the number of bowls are cleaned out. Now, let's look up here and talk for a minute about what we've got. I asked you to bring in beaks at random. You could choose the beak that seemed most suitable to you. For those who brought pliers, why did you choose pliers as a suitable bird beak? What seemed like that was good about the pliers?
Because this is a bigger area to touch food.
Okay. Anything else?
It's easier to catch different sized corn.
Okay. You brought a spring-loaded pliers. Did that turn out to be, well, we'll see if it turns out to be an advantage for you, but what was your thinking about that?
This helped me to catch the small grain.
Oh, so because it's not only spring-loaded, but it's also a fine nosed. Okay, so it has a couple of adaptive features. Lots of people brought clothespins, and I assume that in part it's because they're easy to find. But the idea of a clothespin does seem to have some relationship to bird beaks. For those who brought clothespins, what did you think would make it a good beak? What did you think would make it a good tool to catch food with?
Because the bowl is not so thin, it's a lot of space to catch, and the clothespins is also not so thin like the pliers. It has a lot of area to catch the...
Okay. Okay, anything else? So it means a lot of things, yes?
This is smaller to pick, easy to use. Easy to use.
Easy to use.
Yeah.
That could be very important. A bunch of people brought tweezers. What were you thinking of in bringing tweezers? What seemed like a good tweezer feature for picking up food?
It's more easy to use. There is more things.
Picking up small things, yes. You assumed correctly that it would bring something small as the food. Yes?
And that you can like decide how much pressure you want to use.
Good. So that would be an advantage of it not being quite so springy as a clothespin. Let's see how you did. If you had pliers, how many did you get? Where pliers? Pliers. You got 15. And Pablo, you also had pliers.
Just to...
If you had the spring-loaded pliers, how many did you get?
6.
6. If you had clothespins we have more variety. How many did you get?
9.
9. This is just with the 0. And how many did you get? 2. And 2. 2. And
7.
7. And one more.
12.
Ooh. And tweezers. Tweezers. 6. And tweezers.
6.
Just one.
Just 1.
That's 2.
Oh, excuse me. Thank you. Anyone else? Oh, yes? Fine. Now.
6.
Oh, excuse me.
One more. 6.
Yes. Yeah, but Camille's story. Okay, so here we go. Suppose now, in what way is this like Darwin's natural selection? What's the short resource? Darwin talks about the shortage of resources. What's the short resource?
Food.
Food. The selection pressure in this example is food. There isn't very much. There's 20 popcorn kernels. Last you, let's say it'll last you for a week. So there isn't very much food. And everybody's competing to get as much as they can. Of what you see here, do you see any kind of trend? Do you see any kind of, if you have this kind of beak, it's more likely you'll make it? What kind of beaks have done best, according to our chart? This is our key. So according to our chart, what kind of beaks were collecting more food?
Like,
Okay. The single best, the one who looks like the most likely to reproduce, is this plier attached to Pablo, because the plier attached to Pablo wasn't quite as effective. So maybe you can't go by beak shape alone. Maybe Pablo has other adaptations that make his plier beak work exceptionally well. And then we have 1, 2, 3 of what? Clothespins. Now, clothespins, because they are a more common choice of tool, they are more common, they also have more of a chance, a higher probability of passing on to the next generation. So if we said that of those 20 grains, you had to get at least 6, we'd wind up with a lot of tweezers, which were common in the original population. We'd wind up with a fair number of clothespins that were common in the original population. And we'd also wind up with this, that seems to be an exceptional adaptation, but is unusual. Mutant. The unusually good adaptation that few individuals have. Now, if these individuals breed and have offspring, what can we expect? We've studied genetics a little bit. What can we expect in the next generation? What are we going to see a lot of?
Clothespins.
We're going to see more clothespins and more tweezers. We may not see the plier in the next generation. Why not?
It's only one.
It's only one. It may be a recessive gene. But because the plier is very well fed, it may do a fair amount of breeding. That recessive gene may be retained and may not show up in the first generation of offspring. But if it's common as a recessive, it may start to emerge in the second or third generation of offspring. So here we can see the connection between surviving, eating, surviving, selection pressure, and what genes are left. What is the source of the variability, and what will happen next. Thank you. We can close the video.